Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this first lecture of Module 1 in which we will discuss about background related to Earth, concept of lithospheric plates, different kinds of plate boundaries. Then we will introduce the engineering geology, the definition and highlights of its importance in various kinds of engineering practices involving the earth layer. This lecture will also bring to light the use of rocks and soil by our ancestors for their domestic and shelter related work since historical past. This lecture will also elaborate different phases of engineering geology and engineering geological projects and characteristic of engineering geology experts. In engineering course, today we are going to discuss about the module advances in engineering geology as introduction and significance as a lecture. In this lecture, we are going to cover about background, about definition, about advances and significance, about the phases and characteristic of engineering geology. Friends, as you know, the earth is in shape of the spheroidal nature, is consisting of three broad layers. If we are going to see in interior of the earth as crust, as mantle, as core. Further, the crust is divided in two layers, oceanic crust and continental crust. Mantle is divided in number of layers, upper, middle, lower. This outer surface, which is made up of this crust and some part of the mantle, is recognized as lithospheric plates, and 15 number of plates, it may be vary as per other views. The 15 number of plates is going to envelop the whole surface of the earth. These plates are made up of lithospheric zones, which is ranging in thickness from 0 to 100 kilometer, and the maximum thickness of the lithospheric plate is 100 kilometer. In 15 lithospheric plate, we can divide these plate into categories, namely primary plate and secondary plate. The primary plates, we know about the African plate, about the Antarctica plate, about the Eurasian plate, about the Indo-Australian plate, about the South American plates, about the North American plate, about the Pacific plate, and similarly the secondary type of plate which is smaller in nature, like Arabian plates, like Caribbean plates, like Cocos plate, and etc. These plates are responsible for performing three types of boundary: converging, diverging, and conservative. Here in this phase, we are going to discuss about the diverging boundary. Diverging boundary, if we take a simple example of single plates, these plates are lying above this mantle area, and mantle is purely viscous in nature, Due to temperature difference from lower to upper side in the mantle, there is a development of different type of cycles, diverging type of cycles, which is going to drag this plate. Due to dragging, there is a pulling effect, and due to this pulling effect, there is a development of the number of discontinuities in plates, and these discontinuities are finally responsible for formation of rifts. And we have good example of the shown Narmada rift. Shown Narmada, some people called as Tapti also, Tapti rift. Later on, with continuous diverging movement, there is a flow of the inner material in form of some into volcanic materials and other, and deposited nearby the boundary and responsible for formation of the new plates. Therefore, we can expect more plates in our future. And this type of boundary is responsible for formation of rift basin. Later of rift basin, due to movement of the material, surfacial material in such basin is going to form different type of deposit, and particularly the economical deposit, particularly coal. Coal is generally formed in such type of rift basin. Besides coal, number of minerals also associated with the rift basin. Next type of boundary is a converging boundary, in which two plates are going to collide each other, and after collision the higher plate is moving downside and responsible for the underthrusting. Due to underthrusting, there is a development of one trench type of structure. In trench type of structure, material field and sometimes some sea also in geological past we have reported exist, like Tethys Sea, and the material deposited in this type of depression, when subjected to this underthrusting, then there is a continuous rise. There is a continuous rise in the material and responsible for formation of tectonic type of mountains. Tectonic type of mountains, this particularly, this region is showing rise in altitude. So good example we have Himalaya. Himalaya is rising with 6 centimeter to up to 12 centimeter per year. Due to continuous rise, there is a lot of lithological, lot of geomorphological, lot of climatic changes can be expected. Next type of boundary is simply conservative boundary. The conservative boundary, we are not going to see any type of diverging or converging boundary. Converging type of movement of the plates. Here in this situations, the plates are only moving left to right or slightly up and down. Due to this, there is a formation of number of weak planes or the development of different type of discontinuities within the plates or different type of rival activities, and this conservative type of boundary is not going to disturb anything or destruct any plate, or not going to construct any plate. The good example we have St. Andreas fault. Andreas fault located in state. Here the overall conclusion here, the different type of plate boundaries are responsible for various type of geological activities related to intrusive, extrusive type of ingress of material from the mantle and up to surface or within the crust. and different type of tectonics related processes like earthquake, like erosion, like deposition, like transportation. So various activities are confined to the such type of plate movement. Due to this such type of plate movement, there is evolution of different type of rocks related to igneous, related to metamorphic, related to sedimentary, related to the combination of all these three, and due to latter effect caused by environmental change, caused by the flow of water, caused by the air, caused by the glaciers, caused by the oceans, etc., responsible for change in their intactness, and we are getting some derived material as weathered material or deteriorated material or converted material. We have here good examples. This is one exposure of the rock, well developed rock, and this example I have collected from the Devprayag in Lesser Himalaya. This type of rock, when subjected to different type of natural surrounding environmental changes or inherent changes, then responsible for formation of the derived material or development of derived material as a weathered material. This example also I have taken from the Lesser Himalaya. And then with respect to time or in domain of time, the intensity along with some biological activity is responsible for formation of sand or soil deposits. So therefore we can see, if we are going to look overall our earth crust, subsurface and surfacial process, then we can say that the crust is a host of number of mineral deposit, number of fuel like petroleum and coal, groundwater, geothermal energy, and surfacial. We are going to construct number of projects in service of society and nation, like construction of dam, like road, like bridge, like railway track, like caverns and others. Beside these, we can see the number of natural hazards as well as anthropogenic hazards in form of landslide, in form of subsidence, in form of fragmentation by bombing or by blasting and others. Therefore, we can say that on one side, the crust, earth crust along with some upper part of the mantle is going to provide the sources for improved economy to fulfill the requirement of energy, and for groundwater or water, geothermal energy, and going to provide the number of facility in welfare of society and progressive civilization. If we are going to see the need of civilization, then we can say that the progressive civilizations need energy, needs economy or prosperity, need stability, need safety and environmental clean condition. The society needs energy, economics, but in safe manner, not in unsafe manner. So fulfill all these three, we are going to see about engineering geology. Engineering geology is going to support the availability of these needs. As far as the engineering geology is concerned, we can say that engineering geology is a multidisciplinary science involving earth science and geotechnics. If we are going to see here, we can see that this is lying at the transition of the earth science and geotechnics, where the geotechniques is going to involve number of disciplines such as geomechanics, such as mathematics, such as soil mechanics, such as rock mechanics, such as hydrology, etc. So the ground is dominated by rock, soil or weather material which are going to respond under the discipline of the geotechnics, and the material is confined to the earth science. Therefore, we can say that the engineering geology is actually interaction of geology or the constituents of the ground with applied forces caused by either natural or anthropogenic activities. The number of approaches we have made to define the engineering geology as per International Association of Engineering Geologists, they have defined engineering geology is as a science devoted to investigation, study and solution of engineering and environmental problems. We are going to see about the influence. Engineering geology is useful or essential for proper location, pertinent planning, safe and economical operation, and suitable design, stable construction, and need of maintenance. Besides this is also associated with assessment and implementation of corrective measures related to varieties of natural and man-made hazards and environmental and climatic fluctuation induced problem up to modern. Here we can see the number of stone pieces were utilized by our Stone Age man as evidence from the Son Valley and Narmada Valley. The Stone Age peoples were used such type of tools for hunting and for domestic purposes. It means the persons belonging to the Stone Age have various type of knowledge concerned to selection of strong, durable and compact stones which can be utilized for the various hunting purpose or various cultivation purpose and others. Besides these, Stone Age persons were familiar about the cavities, natural cavities from stability point of view for their shelters to save them from the cold season and from wild animals. We have one good example located in Bhimbedika area in Madhya Pradesh, India. You can see this cave was utilized by the Stone Age person, natural cave. Later on they have realized to develop some facilities for their proper shelters, and they have utilized using stone masonry as a log or for constructing wall for their proper shelters. As far as the time concerned, particularly related to Sindhu, Saraswati or Harappan civilization, the peoples have good idea about the utilization of derived material in form of the burned earth as a brick for development of well-developed structures, utilizing the brick and utilizing the masonry. We have good examples of different type of pond, different type of drainage structures as reported by the archaeologists and historians. This indicates about knowledge concerned to engineering geology. Next, we have number of example related to rock cut structures. We have good example Ajanta, Ellora, Elephanta, cave paintings as well as some statues and others. We have number of stupas, well developed Sanchi stup in central India, particularly located in Madhya Pradesh, and this Sanchi stup was made up of Vindhyan sandstones collected from the Sonbhadra area. Then in South India, the peoples become familiar about the different dam type of structure for distribution of water to the nearby area for purpose of irrigation and drinking. Beside this, we have number of structures related to stupas located in Sarnath area, located in Delhi, and number of monuments developed in different historical periods, Chola king and Mughal and other sultanate. We have number of structure made up of sandstone, particularly Vindhyan sandstone, Arauli sandstone, marbles. We have good example of Taj Mahal. We have different type of fort, varieties of temples and others. These structures indicate about the knowledge of engineering geology concerned to our ancestors. Beside this, we have different writings also written by various writers in Sanskrit, like Mahamata, Srikant Kumar. One of the best writing we have Silp Sastra written by Manshara in 600 BC. This Silp Sastra is written in form of the sutras and different sutras. For example, sutras, here we have described the sutra 198 to 211 is related to classification of different type of rocks in view of their durability. Next, here sutra like 269 to 275 is representing about the durability, strength, about the porosity and others based on the sound after hammering. This work described in form of the Silp Sastra by Manshara, most probably the first such type of documents belonging to engineering geology. However, in these modern days, the first writing of the book was given by Williams, but the Karl Tarjhangi was considered as the father of engineering geology. As far as development project is concerned, we can divide any project in three broad phases. One phase is before construction or development, as a pre-development or pre-construction. Another is during construction or during development. Another post-construction or after development. In pre-construction phase or pre-development, suppose we are taking the example of dam. So in dam, we are going to see about the planning stage, about the design stage, about the investigation stage and other. As the whole business is related to earth crust, therefore there is a role of engineering geology is a must. There is a significant role of engineering geology for stable, safe and economical planning or selection of site or design in pre-construction or pre-development phase. During construction, the number of problems may arise due to response of the ground, which is made up of rocks or soil or weathered material as part of crust. As the geology is dealing with the crust along with these geotechnical aspects, therefore during the construction or development phase, there is a significant role of engineering geology. Without advice of engineering geology, none of the project can be completed with safety and economy, suitable economy. After constructions, the nature is going to accept the structure which is compatible to the nature or acceptable to the nature. Therefore, there is some minor type of damages or sometimes disasters also, but generally minor type of damages resulting some development of discontinuity or damage or deterioration require maintenance after proper monitoring and observations. So overall we can say that the engineering geologist is going to play a very important role in case of any development project, either it is related to construction of dam or construction of building or road or bridge or extraction of petroleum or extraction of geothermal energy or disposal of nuclear waste, carbon dioxide sequestration or any type of practical utilization involving the earth crust. Now we are going to discuss about characteristics of engineering geology. As you know, the engineering geologist is required to translate different geological information for proper understanding by the other fellows of team. The other member of team of a project maybe belongs to the mechanical engineering, maybe belongs to electronic engineering, maybe belongs to electrical engineering, maybe an economist, maybe a social science, maybe a psychologist, therefore maybe audit person. Therefore the engineering geologist is a person who are able to translate the mood or the response of this strata with respect to the expected applied force or applied load or applied stress caused due to construction of engineering structure or due to excavation of strata in form of tunnel, caverns and others. Therefore, if we try to summarize the characteristic of the engineering geologist, then we can say that the engineering geologist should be competent enough in all branches of geology and able to translate geological information for proper utilization of persons belonging to other discipline. Next, the engineering geologist should be smart enough and able to perceive the things related to the ground properly, sincerely and carefully. For this study, we have designed this course with help of these 3 books and some website materials from Wikipedia and others. So well, and this book by the Waltham and the Kashavulu. These are some recent advances in the engineering side, so that can be helpful for you. As far as conclusion is concerned, we have discussed about the processes governing the movement of the plates in form of diverging, converging and conservative. Then about the different type of rocks, about the definition of engineering geology, about the application and significance, and related to our utilization concerned to our society, particularly our ancestors and in modern days. Friends, today we have discussed about Earth, concept of plate tectonics and plates, different type of plate boundary, needs of society for progressive civilization, brief about rock, weathered material and soil, advances through historical perspective from Stone Age up to recent, significance of engineering geology in general and particular in different phases of any engineering geological project. Then role and characteristic of engineering geology expert. As per our discussions, the engineering geology is practically application of geological knowledge in engineering practices involving crust and upper part of mantle that include planning, identification of location, design, construction and post-construction monitoring, repair and maintenance. We have discussed the art of engineering geology and the status of engineering geology for proper development and protection of natural hazards, location of hydrological bodies, instability aspects of slope. Thank you